Hello, hello, hi everyone. So I'm having some computer issues in that my frame rate is dropping, so I'm apologizing in advance. In fact, I'm pretty sure it may have affected the previous video too, so I apologize for the frame rate dropping, but it shouldn't have affected the material being written down, but if it did, just shoot me email, let me know. Okay. Right. So from Unit 3 material, there was a bullet point that I made that got skipped technically. The bullet point was sometimes integration by parts makes the problem more legible. Now, for all of these four problems that we're seeing today, these are all instances of making the problem more legible. Okay, so we're going to start off with first the integration of ln. Now, we can't use substitution here because its derivative, ln's derivative, does not appear anywhere in this expression. So we should probably just do an integration by parts and see if that makes it more legible. Well, if I'm taking the whole thing, I'll take the whole thing, ln of x. And that means dv will be the just dx. V will be x then, and then du will be 1 over x dx. Now, write the whole integration by parts. We have x times ln of x minus the integration of v, which is x times 1 over x. 1 over x dx. We know that cancels out to just be 1. So we have x ln of x minus the integral of dx. And we know that guy. It's x minus ln of x, or sorry, not minus, times ln of x minus an x plus c. And that would be our answer. Now, keep in mind the technicality I mentioned before of what if we want to double check our answer. We can quickly double check our answer. Take the derivative of this guy. So we have the derivative of x ln of x minus x. We have a product rule where first take derivative of x, which is ln, and then derivative of ln. So plus x times 1 over x. And derivative of that is negative 1. That will simplify into a 1. So 1 minus 1, that cancels out to be ln, which is what we originally have. So keep that in mind as we do these next problems, how this makes it a more legible problem. Obviously, not obviously, but as we keep going, there's going to be an increase of difficulty. So let's start with arctangent. We have u to be arctangent. That means du will be, here, I'm pulling it up on my phone, 1 over x squared plus 1 dx. Let's double check. Yes, we're good. Okay. And then dv is going to be that dx, and v is going to be that x. So that means we can set it up as x times, I'm just going to write like this tangent inverse of x minus this pairing, x over x squared plus 1 dx. Now, what is this problem? Well, this has now become a definite substitution problem. Because of the technicality that we know the derivative of x squared plus 1 is partially available right here now as a multiplicative product. So we're going to do that. So let's just let u, or, yeah, let's do u in this color. The x squared plus 1 du is simply going to be 2x dx. We see the x and the dx, we now see the 2, so we divide out the 2. 1 over 2 du is equal to x dx. And then I'm going to go ahead and plug that in. I'm just going to only rewrite that part. We have 1 over 2. I guess I'll include the negative just in case. 1 over 2 du, and then is 1 over u. We know that this guy its integral is simply just ln of u and then plus c. And then we need to plug in back x to get the final result. X times tangent inverse of x minus 1 over 2 ln of x squared plus 1 plus c. And that's going to be your answer. Now, granted, from here, you can still double check, and that goes for all of these, by doing the derivative. And do the derivative of this, and it should match up to tangent. Do I want to do that one with you guys? No, I think I will leave that to you guys. Okay, let's do number 3. Number 3, again, we're doing the attempt where we do the integration by parts to just make the problem legible, more legible. So u will be sine inverse of x. So the derivative of that will be 1 over the square root of 1 minus x squared, and then dx. So dv will be dx, and v will be x. Plugging this all in, I'll get sine inverse of x times x, I'll put that here, minus the integral of this bottom line. So we have x over square root of 1 minus x squared dx. From here, I'm going to go and use substitution. U is 1 minus x squared, and then du will be negative 2x dx. We have a negative, we have an x, we have a dx. So really the only thing that doesn't appear is the 2. So I'm going to get rid of the 2. So negative x dx. So from here I'm getting the negative x and dx to write it as plus 1 half 1 over square root of u dx, or du, excuse me. Then from here I can go ahead and just do the integral of that. So the integral of that is hold on, I don't know why I'm going slow, or I'm going maybe too fast. I'm just gonna do it step by step. I was trying to do it in my head. 1 half times this negative oh yeah, so negative 1 half plus 1 over negative 1 half plus 1. That's gonna be 1 half each. So that's will cancel out. And then we're left with square root of u plus c. And then we're going to go ahead and plug in back u to get the final answer. And the final answer is x sine inverse of x plus the square root of 1 minus x squared plus c. And that will be your final answer. Last one, number 4. Number 4 is taking the whole expression, cosine inverse of x dv dx. I don't know why I'm switching between semicolon and, colon and equal sign. So this one, I believe it's the same thing, just a negative on top. Let me just double check that. Yeah, so negative 1 over integral 1 x squared d, going too fast, v is x. So the setup is x cosine inverse of x minus a negative x over square root of 1 minus x squared dx. We're going to do actually the exact same substitution as before. The only difference is that we have now a double negative situation, but it shouldn't change anything drastically. we have a negative 1/2 integral of 1 over square root of u du. And we know that this is just negative square root of u plus c. And then I'm going to write the final answer when plugging in back u to be in terms of x. X cosine inverse of x minus the square root of 1 minus x squared plus c. Great. That's going to wrap up the worksheet video, guys. Um, Let me know if you have any questions, and if you get stuck on the homeworks, let me know. This one's a little bit more because this is a very important trick that we need to know for integration. So make sure you get a hold of this. If you don't, I definitely don't mind like remaking their video, making their worksheet, but you just gotta give me that feedback. All right, I'll see you all on the next one. Bye bye.